Hello. In this video, we're going to look at repeated roots and reduction of order. So in particular, we're talking about solving a homogeneous linear second order differential equation with constant coefficients whose characteristic equation has repeated roots. Okay, so what would that look like? So we'd have ay double prime plus by prime plus cy equals 0. So we have this is a homogeneous linear second order differential equation with constant coefficients. We go through and we form the characteristic equation. We get ar squared plus br plus c equals 0. Then we go through and we solve the characteristic equation. We end up with a repeated root. So when does that happen, right? So if we went through and used the quadratic formula, we get negative b plus or minus the square root of b squared minus 4ac over 2a. Right, so that's only going to happen if this term ends up going away, right? The plus or minus is what gives us the two solutions. So we'll only have a single solution if we just have negative b over 2a. So so that single solution is going to be negative b over 2a, and it occurs. So all this is actually going to be important. That's why I'm explaining it. It occurs when b squared minus 4ac equals 0. Okay, so suppose we have a homogeneous linear second order differential equation with constant coefficients, and we get a single solution, a repeated root to the characteristic equation. Then what happens, right? So what we have done up to this point in our previous videos is every time that we solve a characteristic equation, we just go through and take that solution and plug it in as the exponent of an exponential function along with t, and said that it gives us the form of a solution. So with all of the previous cases, when we had complex roots or we had real roots, we had two solutions, and so we just could take the two solutions and we could plug each one into two separate formulas for y and end up with two solutions. So the unique thing about the repeated roots case is that we only have one solution. So what's the other one? How can we go through and come up with the other solution? Okay, so what could the second solution be? Right, to go through and try and answer that question, what we're going to do is we're going to look at a specific problem and go through and try and solve it. All right, so let's go ahead and start off with, we have y double prime plus 4y prime plus 4y equals 0. So second order differential equation, linear, homogeneous, all that stuff. So form the characteristic equation. We get r squared plus 4r plus 4 equals 0. And then you could factor this. This is r plus 2 squared equals 0. And so we'd get r equals negative 2. So then we know that one of the solutions is going to be e to the negative 2t. Okay, and so you could check that if you'd like. Take that, plug it back in. It's going to work. We went and showed that in the first section that we discussed, the characteristic equation. Okay, so what could the other solution be? Well, what do we know about this single solution? And again, we talked about this back in the first section, and that is that we could go ahead and take a constant multiple of this and it would still work, right? So if this works, then a constant multiple is not going to change anything. You could try taking that, plugging it in. You're just going to end up with an extra constant here, here, and here, and it's just going to end up canceling out. And so we could just add a constant like that, and it does not, and it still would be a solution. So the next thing that, the next place you might go to is, well, I could take my e to the negative 2t and multiply it by a constant, and it would work. So is there something else I could multiply by and that it would still work? So if you thought about it long enough, that might be an idea that occurred to you. And so that's what we're going to do, is we're going to try that and see what happens. And so we're not going to pick something. So we're not going to go through and put sine t here or something like that and just start guessing stuff. Instead, what we're going to do is we're going to actually say, we're going to make a guess. Oops. We're going to make a guess that y equals v of t times e to the negative 2t. And then we're going to try and solve for what function we could put there, right? Okay, so rather than just start guessing functions, guess sine, cosine, I don't know, natural log, just guess putting stuff here and see if it works. Instead, we're gonna go ahead and guess something generic and then see if we could go through and solve for what specific thing would actually work. All right, and so once we've made this guess that y would equal that, we want to be able to go through and take this guess and use it in our formula. So to do that, we need to know y double prime and y prime. So you have to go through and find y prime. And so to do that, you need to use product rules. So we've got first times the derivative of the second plus the second times the derivative of the first. And then we could go through and find y double prime and just do the same thing again. So we're going to have first times the derivative of the second. So that's going to give us 4e to the negative 2t plus the second, which is negative 2e to the negative 2t, times the derivative of the first. So we get v prime. And then we need to use the product rule on this. So we're going to have e to the negative 2t times v double prime plus v prime. Hold on, try to be consistent here with whether I'm going to use those parentheses t's or not. You could just leave those off. And then times negative 2e to the negative 2t. All right, and then once we've got our three formulas here, we're just going to take them, we're going to pop them into our original equation and see what happens. All right, so y double prime is this. So I'm going to do, there is a simplification step you can do here where you've got negative 2e to the negative 2t v prime, and there's a second one there. So I'm going to go ahead and combine those while we're simplifying here. So we're going to have 4, and I'm going to shorten this and get rid of the parentheses t just for a little shorthand to save some space. So we're going to have 4 v e to the negative 2t, okay? And then we're going to have a negative 2 v prime e to the negative 2t, and then another negative 2, so we're going to have negative 4 v prime e to the negative 2t. And then what's left, we've got e to the negative 2t times v double prime. So we'll have v double prime e to the negative 2t. So that's y double prime. And then we're going to have plus 4 times y prime. And what is y prime? It's this here. So that's going to be negative 2 v e to the negative 2t plus v prime e to the negative 2t. And then we have plus 4, right? Plus 4 times y. And so y is going to be this thing. So it's going to be v e to the negative 2t. And what do we know about that? It equals 0. So we're going to get equals 0. And then what happens after that? All right, so we need to do some simplifying here. So we've got 4v e to the negative 2t minus 4v prime e to the negative 2t plus v double prime e to the negative 2t minus 8v e to the negative 2t plus 4v prime e to the negative 2t plus 4v e to the negative 2t equals 0. And let's see what happens here. So we've got, here's a 4v e to the negative 2t and another 4v e to the negative 2t. Combine those, you get 8. That will cancel with this negative 8. And we also have a negative 4v prime, positive 4v prime. Those will cancel. And so what pops out of this? V double prime e to the negative 2t equals 0. And let's just stay on this page just to kind of keep it all condensed. So what does that mean? So we've got v double prime e to the negative 2t equals 0. So we could multiply both sides by e to the negative 2t, or by e to the positive 2t, and this would turn into v prime equals 0. And then you could go through and just integrate this. So you could integrate both sides, and you'll get v prime equals a constant. And then you could integrate a second time, and you'll get the constant times t plus a second constant. And so what have we accomplished here? Well, we went through and we made a guess, and we left v generic, and then we just saw what happened as we went through and, took our solution, figured out, how to take that and plug it into our differential equation, and then it just turned into this. All right, so what is the function that we would have to put here so that this would actually turn out to be a solution? It's c1t plus c2. What happens if we just take that and pop it in? We're going to get y equals c1t plus c2. That's v of t times e to the negative 2t. And then if you multiply that out, look at this. We're going to have c1t e to the negative 2t plus c2 e to the negative 2t. Now compare that. What did we say that we had? So we said one of our solutions was e to the negative 2t, and we could take multiples of that and it would still work. All right. And if you look over at what we ended up with what looks like our previous two solutions to these characteristic equations. We had two parts. One of them, look at that, it's the first part. So this is our first solution that we got. This is y1. And what is this? So this is the new solution that we got. So that's our second solution. So that's our second solution. So if we wanted to, we could go through and just do y2 equals. But here's the thing. If we did y1 equals e to the negative 2t and y2 equals t e to the negative 2t, we're just going to end up taking linear combinations. And so it's actually just going to end up looking like this. So this right here is the format of the solution. It's like we skipped a step here. And you could just take this and box it in and just say, there you go. So if you have a repeated root, then you can go through and just use this structure to go through and create your solution. That looks like a -4 there. This is supposed to be a -2t. So how do you get from here, like instead of going through and doing all the steps, going through and doing all these intermediate steps, how do you get from here over to here? Well, the structure is if you go through and solve and you get a repeated root, -2, you just form this structure and put the -2 here and here. That's where the -2 ended up going. The rest is going to be the same every single time. So we're always going to get c1t e to the, whatever the r is times t plus c2 e to whatever the r is times t. Okay. So that's what we ended up with in this specific situation. Now the question is, can we go through, is this always true? Does it change if we, was there something special about this situation that caused this to happen? Was it because we had r equals -2? Or as I just said, can we just go through and whatever the r is, can we just pop it in here and call it a day? Well, let's find out. Let's go through and make everything generic and see if it changes anything. All right, so how do we go through and do that? Well, we're going to start off with ay double prime plus by prime plus cy equals 0. You form the characteristic equation. And then you go through and you solve it, and you get r equals negative b over 2a. And then we go through and we get to the point where we have y1 equals e to the negative b over 2a. And then we go through and we just make a guess. So I'm just repeating everything from the previous page, but I'm just doing it in a general setting instead of the specific case. So we're going to have v times e to the negative b over 2a. And then from there, you go through and you find y prime. So you get first times the derivative of the second plus the second times the derivative of the first. And then y double prime, we have first times the derivative of the second plus the second times the derivative of the first. All right, so product rule on this piece. We got to do product rule on this piece too. So we have first derivative of the second plus second times the derivative of the first. Oops, oh, hold on. Got a little lost in there. All right, and from here, we just want to go through and take this and substitute it back into our original. Let's go through and do that simplification step that we kind of just did. Let's do that first this time, just because the equation is a little bit more complicated with these negative b over 2a's in here. So this first part stays the same. That's the only term that has v. So we're going to have v b squared over 4a squared e to the negative b over 2a. And then what do we have here? So this is negative b over 2a v prime. We've got another negative b over 2a times b prime. And so if you add those, you're going to get negative 2 over 2a. So we're just going to have negative b over a e to the negative b over 2a v prime, and then plus e to the negative b over 2a v double prime. Okay, so now we're taking that and we're going to pop it in here. So we'll have a times that thing okay, and then we have plus b times y prime. And so what did we get for y prime? We got this. So that's going to be v. Let's actually hold on. Yeah, no, that's fine. That's fine. I'll just put parentheses here. So v negative b over 2a e to the negative b over 2a plus e to the negative b over 2a v prime. And then what do we have left? So plus c times y, which we're saying is v e to the negative b over 2a. And just about out of space, so we know that that equals 0. Okay, so we want to go through and distribute the a here. So if we do that, we're going to get v b squared over 4a e to the negative b over 2a, then minus b e to the negative b over 2a v prime, and then plus a e negative b to the 2 b over 2a v double prime. And then what's going to happen here? So we've got b times this. That's going to be a minus b squared over 2a v e to the negative b over 2a plus b e to the negative b over 2a v prime plus c v e to the negative b over 2a equals 0. All right, let's take a look here. So we've got negative b e to the negative b over 2a v prime, positive b e to the negative b over 2a v prime. So those are going to cancel. Okay. And then what's left here? We've got all three of these terms have v in them, so we can go through and combine those. So we're going to get v, and this one's going to have b squared over 4a. Actually, let's factor out the e to the negative b over 2a at the same time. So we're going to have v e to the negative b over 2a. And then we've got this guy first, and then what else has just v, this guy? So we're going to have minus b squared over 2a. That's the next one. And then plus c. All right. And then on top of that, we're going to have a e to the negative b over 2a v double prime. And yeah, let's stay on this page here. We'll just do an arrow to represent the next step. So here we want to go through and get common denominators. So we're going to have v e to the negative b over 2a. So we'll use 4a for the denominator. So we're going to have b squared over 4a minus 2b squared over 4a plus 4ac over 4a plus a e to the negative b over 2a v double prime equals 0. Okay, I guess we're going to have to go to the next page here. All right, so what's going to happen to this? So you've got b squared over 4a minus 2b squared over 4a. So that's going to become a negative b squared over 4a. So we'll have v e to the negative b over 2a times negative b squared plus 4ac over 4a plus a e to the negative b over 2a v double prime equals 0. All right, so let's just take a look, make sure we're okay with that, right? So v e to the negative b over 2a, v e to the negative b over 2a, so I just copied that. And then this piece here, we've got b squared minus 2b squared plus 4ac. So b squared minus 2b squared is going to become a negative b squared. And then the plus 4ac is what's left. Just transcribe that here, all over 4a. All right, so negative b squared plus 4ac. You could factor out the negative there. And there's a reason I'm doing that. Just pull out that negative, and then this would become b squared minus 4ac over 4a. So what do we know about b squared minus 4ac when it comes to a repeated root problem? You know, if it comes to a problem where you go through and you solve this using the quadratic formula, if you solve this using the quadratic formula and you just get negative b over 2a, the only way that that can occur is if b squared minus 4ac equals 0, right? This term has to go away for you to end up getting negative b over 2a. So if b squared minus 4ac equals 0, then this part equals 0 and this whole term goes to 0. And so we end up with a e to the negative b over 2a, v double prime equals 0. A is a constant. You could divide both sides by it. E to the negative b over 2a is always positive. You could divide both sides by it. And so you get v double prime equals 0, and then integrate, and you'll get v prime equals c1, and then integrate again, and you'll get c1t plus c2. Then going back to our definition here, we said that y equaled v, whatever it is, times e to the negative b over 2a. So just take that, and you can just pop that v in, and we'll get y equals c1 t plus c2 times e to the negative b over 2a, or y equals c1 t e to the negative b over 2a plus c2 e to the negative b over 2a. And that's our solution. And that's the same thing that we got last time. It's just now written in a not written in a generic form. And so what it says is that it says if we go through and solve the characteristic equation and we get a single root, whatever that single root is, you can just take it and pop it in as the exponent. Oh, whoops, we forgot the t here. It'd be b over 2a. Did I do that the whole way through? Oh, whoops. Oh, geez. Oh, no. All of these should be times t's. Okay, well, you can just go in and fill in all those in your notes if you want. There should be times t's throughout these. It was shorthand, right? Shorthand. They're just saving space. I would not have been able to fit all this in if I put in all those times t's. Okay, anyway, so you get the idea. So that's what this formula says is that whatever the r is, you can just pop it in here and here times t, and you're all set, and that's the solution. So that's what we just went through and proved. Okay, so the last thing for the repeated root problem, and then we're going to look at reduction of order, is to go through and do an example. All right, so suppose we had y double prime minus y prime plus 1/4 y equals 0. Then form the characteristic r squared minus r plus 1/4 equals 0. All right, that's r minus 1/2 squared equals 0. So r equals 1/2. Oh, whoops, I forgot the initial conditions. This is an initial condition problem. Y of 0 equals 2, and y prime of 0 equals 1/3. Okay, sorry for that. And then once you get r, you can just take that and say our solution, just pop that in for the exponent. So we're going to get c1t e to the 1/3 t plus c2 e to the 1/3 t. It's that simple. Okay, once you've got your solution here, you can go through and solve for c1 and c2. We get y of 0. Y of 0 is going to kill this term because of the t, and so we're just going to get c2, and then so 2 equals c2. And then to go through and solve for c1, we need to find y prime. So y prime, you could go through and use the product rule here. So, oh, yeah, we're going to leave that. So c1t times the first times the derivative of the second. So we're going to get 1/3 e to the 1/3 t plus the second e to the 1/3 t times the derivative of the first, which is just c1. And then for this guy, this is what I was about to do with the c1. You got to take the 2 and just pop it in there. So we're going to have, when we differentiate this, we're going to have the 1/3 comes out and it gets multiplied by 2. So we're going to have 2/3 e to the 1/3 t, like that. And then we have y prime of 0. If you plug in 0, that kills that term because of the t. So we're going to get c1 plus 2/3. And then y prime of 0 is 2. So we get 2. Wait, hold on. Checking my notes here. Something does not appear correct. So we've got the 2 there. 2/3. Okay, no, that looks right. And so if we pop that in, we're going to have 2 minus 2/3. So we're going to have 6/3 minus 2/3. We're going to have 4/3 equals C1. Oh, I see it. So let's just fix this. So this is supposed to be a 2. And that's supposed to be a 2. And that's fine. And sorry to wreck your notes. If you're not taking notes, then I'm not really sorry, because it's just going to cost you about 1 minute to fix this. Okay. So now we have the 1/2 comes out, it gets multiplied by the 2, and so there's supposed to be a positive 1 there. All right, that's going to fix it. So we're going to end up with positive 1 there. And then y prime is 0. Oh, did I make another mistake? Oh, geez. That's supposed to be a 1/3. Then plus 1. It's going to have to be good enough. I'm not going to remake the video over this, though. So we take 1/3, subtract 1, we get -2/3 for C1. Oh, and take a look. Now it agrees with my notes. And so we get y equals -2/3 times t e to the 1/2 t plus 2 e to the 1/2 t. Okay, so outside of that little that typo, really a typo, copying the 1/2 and turning it to 1/3. Outside of that little typo, I think that's a good example. That should help if you go through and try to use this to solve problems. All right. Second thing for this this video is we're going to look at reduction of order. All right, so the question is, this method that we just used, could we go through and use this in any other circumstances? In particular, in this case, what we had is we had a differential equation, and we had one solution, and we used the one solution we had to go through and find the other solution. So what if we had a differential equation, and we had one solution? Could we go through and do something similar? Right? So that's the question. Can this method be used to solve other problems where we have one solution? So let's suppose we have a differential equation and y1 of t is a solution. So this is all generic, right? We're not dealing with a specific problem. We're starting with the general case. We have a second order differential equation. It's homogeneous and linear. Does not have constant coefficients, though. Notice does not have constant coefficients. So this is a more challenging problem to solve in general. So suppose we have linear homogeneous second order differential equation, and we have one of the two solutions. And we wish we really had the second, but we don't. So in order to go through and try and solve it, we're going to say, hey, can we go through and use the solution we have to try and solve this by just taking v and multiplying it by y1 of t? Actually, hold on, let me do this. Let's do this. So taking v of t and multiplying it by y1 of t, and then we're going to shorten this to just v times y1 to save some space. We're just going to drop off those parentheses t's. Okay, so if that's our guess, v y1, we're going to do this for, I think, the third time. So we're going to get v times first times derivative second plus second times derivative first. And then we'll get y double prime. So we get first, derivative second, second, derivative first, first, derivative second, plus second, derivative first. And then if you take a look at that, we should have two that have our y1. There's missed the y1 there. Two y1 prime v primes, and so we can combine those. So we get v y1 double prime, 2 v prime y1 prime plus v double prime y1. Now take those, pop them up into the original differential equation, and let's see what happens. So this is the this we're going to put in place of the y double prime. So we're going to have vy1 double prime plus 2v prime y1 prime plus v double prime y1. And then we're going to have p of t times a y prime, which is vy1 prime plus y1 v prime plus q of t times y. So that's just vy1. And that equals 0, because we're just going to popping stuff into this original equation. All right. So the next thing that we can do is go through and group the things that contain v. So we've got a v here. We're going to have a v here and a v here. Watch what happens when we do this. So we're going to have v, and I'm going to go ahead and factor it out. So we're going to have y1 double prime. Okay, and what's this one going to give us? This is going to give us, so we're factoring out the v, so we're going to have p y1 prime. And then here we're going to have q of t y1. All right, and so once we've done that, what's left? So this is used up, this, and this. And so we still have a 2v prime 1 y1 prime and a p of t y1 v prime. So we're going to have v prime times, actually, yeah, that's fine. I'm just going to change the order in a second. So we're going to have v prime times 2y1 prime plus y1, right? So it's this term and this term together where I've pulled out the v prime. So we're going to have 2y1 prime plus the, oh, whoops. Yeah, maybe you should be a little more careful and actually multiply this out first and do it in a separate step. It's going to be, there should be a p of t here that I almost forgot, right? So this is p of t times the y1 v prime, and then we pulled out the v prime. Okay, yep, that made that look harder than it was. Sorry about that. And then last but not least, we've got the v double prime y1 equals 0. And then, so what happens here? So this thing here, take a look at that. So one of the things you need to notice, notice it looks exactly like this, except we've plugged in y1 prime. Well, what do we know about this with y1 prime plugged in? y1 is a solution. So, or sorry, with y1 plugged in, not y1 prime. Well, with y1 plugged in, since y1 is a solution, we know that this equals 0. So this whole thing is 0, just killed. And then here I'm going to change the order around just to simplify this a bit. So we've got v double prime y1 plus v prime times 2 y1 prime plus y1 p of t. Okay. So what is this? Right. So v is the unknown. Right. So we said y equals v, and we don't know what v is. y1, that's known. That's given. We're given a solution when we start the problem. P is known. That's the thing that's being multiplied by y prime. So we've got something known here, something with t in it, right? Presumably, because it's y1 of t. So we've got some t stuff here. You've got some t stuff here. You've got some t stuff here. And so what we have is we just have this v double prime and v prime. Those are unknowns multiplied by a bunch of t stuff. Well, if you go through and just do a real simple substitution, so let's just say let w equal v prime, then what's going to happen is this is going to turn into w prime y1 plus w times 2 y1 prime plus y1 p of t equals 0. So this result here, this is a first order differential equation in W. Why is it a first order differential equation? Well, it's an equation that contains an unknown function, w, and we have it w prime and w. So the thing is notice the w's and the w prime and the w, They are not inside of other functions. They're to the first power, so that means it's linear. This is a linear first order differential equation. And in earlier videos, we went through and we showed how to solve linear first order differential equations. So we can go through and solve this using the linear technique. And the other thing too is that it's not as obvious. I could make it more obvious with a few more steps, but it's also separable. Okay, so it's not only a first order differential equation, but it's solvable using our techniques from earlier in the course. All right, so solvable from earlier techniques. I don't have enough space to write all that down. And so what we want to do is we could go through and from here we could solve it. So this is really as far as we can get generically, but we've gotten to a point where we could solve this if we just continued onward. So to finish this, let's go through and actually try this on a specific example and see what it looks like. What happens if we go through and try this on an actual problem? How can we use the work that we have just done? Because the whole point in taking a general problem and going through and doing a bunch of stuff is to skip the steps that would be the same every single time. So if we're going to have a specific P of t and a specific Q of t and a specific Y1 of t, then if you go through and just do this step again, you're just going to have whatever the Y1 is, you're just going to plug it in here and 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 here. And you're going to end up in this same spot where this cancels. So all these steps are going to be redundant every time. And so what we really want to do is we really want to just jump here to this last step where we could not proceed until we actually had a specific problem to solve. So that's what I want to show you, is how to go through and use this method without just repeating it every single time. All right, so let's say we're given 2t squared y double prime plus 3t y prime minus y equals 0. And we know that y1, we have a solution. It's y1 and it's equal t to the negative 1. Okay, so if we're going to use the work that we did previously, notice the format it's in. It's in the format where we don't have a function in front of the y double prime. So we need to go through and put it into this format if we're going to use it. Okay, so to do that, you need to get the coefficient on the y double prime to go away. So to do that, divide both sides by 2t squared. So if we do that, we'll have y double prime 3t over 2t squared, y prime minus 1 over 2t squared, y equals 0. And then we could simplify that to this y double prime, and we're going to have 3/2 t to the negative 1 y prime minus 1/2 t to the negative 2 y equals 0. So this is P and this is Q, right? Compare that format, what we just have, to this. The thing that's multiplied by y prime is P. The thing that's multiplied by y is Q. Multiplied by y prime, P. Multiplied by y, Q. All right. So you could go through at this point and do your guess, take y, set it equal to v times the y1 they gave us, set it equal to t to the negative 1. You could do that. You could do v times y to the negative 1, and then you could differentiate and differentiate again and substitute into the original and group and cancel. But instead, how about we just jump right to, well, how about we just jump right to here? We're just going to jump right to here. So we're going to go ahead and write, let W equal V prime. And using that, what we're going to end up with is the equation. We're going to end up with W prime Y1. So we're going to have W prime. And then what's Y1? It's t to the negative 1 plus W times, and now take the stuff inside here. So we've got 2 times y1 prime. So we're going to have 2 times y1 prime. So you have to differentiate y1. So we're going to have negative t to the negative 2 plus, and then next we have y1 times p. So we're going to have y1, which is t to the negative 1 times p. And what was p? 3/2 t to the negative 1 equals 0. All right, and then so from there, I guess if you really, this maybe looks a little bit goofy to have a v where we haven't put a v before, so maybe you should go ahead and say y equals v times y1 as well. All right, so we've got y equals v y1, and we'll just throw, don't put a y1 though. What did I just say? Go ahead and pop it in there. So we're going to have t to the negative 1. All right, anyway, so from here you want to just simplify this. So what is w prime? That's dw over w. Yeah, so this is going to be, no, hold on, what am I doing? Oh, there we go. dw dt. Sometimes the brain just shuts off. All right, and then we're going to have t to the negative 1. And then what's this going to simplify into? It's going to be w. We're going to have negative 2t to the negative 2. And then here we're going to have plus 3 halves t to the negative 2 equals 0. And then we're going to have dw dt t to the negative 1. This is w. And then what do we get out of here? We've got negative 2 t to the negative 2 plus 3 halves t to the negative 2. So we're going to get negative 1 half t to the negative 2 equals 0. And then, as I said before, this is separable. It's like not really obvious, maybe even right here. But you could take this term, move it over to the other side, and you're going to get dw dt t to the negative 1 equals, what are we going to have here? This is going to be w times negative 1 half t to the negative 2. And then you're going to take the dt and t to the negative 1, move it over to this side, take the w, move it back to this side. We're going to get dw over w on this side. So we're going to be multiplying by, let's just do this. Let's do this. dt over t to the negative 1 times dt over t to the negative 1. And so the w moves over. Here we're going to have negative 1 half. And then here we're going to end up t to the negative 2 over t to the negative 1. So we're just going to have t to the negative 1. All right, and then we could integrate both sides. Oh, and I forgot the dt. And then we're going to integrate both sides. And on this side, we're going to get ln w. And over here, we're going to get negative 1 half. And then integral of t to the negative 1 dt, that's going to be ln t plus c. And then you can take both sides and, oh, let's just go to the next page. Let's just go to the next page. So what do we have? We have ln w, negative 1 half, ln t plus c. So you can take both sides and plug them in as the exponent of e. So you're going to get w equals, so you could split this up into e to the negative 1 half ln t times e to the c. The e to the c you can just replace with just a regular c. And so you're going to get e to the negative 1 half ln t, which you can take the negative 1 half and bring it inside. And so we're going to have c e to the ln t to the negative 1 half, which is c t to the negative 1 half. Okay, hold on. Okay, another mistake, well, minor mistake here. When I took this term and moved it to the other side, it should become positive 1 half. All right. There we go. And that fixes that. And then, so now we've got w. And what do we know about w? W equals v prime. So we'll get v prime equals c t to the 1/2. And then you can integrate both sides, and you'll get v equals, 2/3 c t to the 3/2 plus another c, and let's just number the c's here. We'll make that c1 and that one c2. And then if you take that v and plug it into this v here, we'll get y equals 2/3 c1 t to the 3/2 plus c2 times t to the -1. And so if you multiply that through, we're going to get 2/3 c1 t to the 1/2 plus c2 t to the -1. Okay, and so that's the form of our solution. Now let's take that and look back, right? So what happened here? So we had a differential equation. We had one solution, and then we went through and did a bunch of stuff, and we ended up getting that the general solution is going to be this. So what was the second solution? This is multiples of the first solution. So this is the first solution. And so our second solution is right here. That's the second solution. Right. So when it comes to the second solution, you just ignore the C1 and the 2/3. That's just a multiple of the second solution. So the second solution is t to the 1/2. So the two solutions to this are actually t to the -1. That's the first solution, and t to the 1/2. That's the second. Okay, so let's just recap, right? So if you want to go through and use this method, oh, and I forgot, did I mention this? So the reduction, or why is it called the reduction of order method? Because we start off with a second order differential equation, and then we turned it into a first order differential equation by going through this process here in the middle. So we reduced the order from second order down to first order, and you can do that if you have one of the two solutions. Okay, but as far as going through and solving it, first, to use all this stuff, we have to make it look like this. So we went through and got y prime by itself, simplified, that got us p, that got us q. Once we had done that, all of these steps are going to be the same every single time you solve it. So you really can just jump over them and just jump down here. So that's what we did. We went ahead and said, let w equal v prime, let w equal v prime, comma, and then we just wrote the rest. So I'm literally just took this piece here and I just copied it over, substituting what y1 prime, and p are, right? So that's what we did. So we've got w prime, there's y1, that's that, plus w, wrong direction, plus w, and then inside here, I went through and I put 2 times y1 prime, so 2 times y1 prime plus y1p, y1 times p, right? The p being the stuff that's for y prime. And then from there, it's just simplify, 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 move stuff around, integrate, move some more stuff around, manipulate, get w by itself, integrate again, substitute for w, integrate again, get the solution, plug it into this little mini equation, which you do need, and I forgot to mention earlier, and then distribute, and then you're done. Okay, so that's the reduction of order method, and that concludes the video. My apologies, this one is a little rough, a couple little mistakes here and there, but hopefully everything makes sense, and the mistakes ended up, we found them and simplified them in real time, which is a minor miracle. Normally you got to start videos over all over again. But anyway, so I'm just going to stop talking. That concludes the video. Thank you for watching. See you next time.